Well, thank you all for being here today, this morning. It's a beautiful morning, one perhaps of the last, or perhaps the last good morning season. We've checked all, I'm pretty sure, the weather. We're having bad weather tomorrow. Welcome to our distinguished lecture today. I'm actually going to hold on for 1 second because our chair is coming along. Maybe he has a few words to say. Go on? All right. So I would like to welcome you to our first ever distinguished lecture organized by the Department of Civil Structural and Environmental Engineering, the Institute for Sustainable Transportation and Logistics, and the Transportation Group. Today I have the great pleasure and privilege to be introducing to you Professor Chris Hendrickson. Dr. Hendrickson is the Hammerslag University Professor and Director of Traffic 21 Institute at Carnegie Mellon University. He's one of the very few in our field members of the National Academy of Engineering and the Editor-in-Chief of the Journal of Transportation Engineering of the American Society of Civil Engineering, one of the most popular and most prestigious journals in our field as well. He received his bachelor's and his master's from Stanford University. Then he received the master's of philosophy from Oxford University, and finally he came back to the US to receive his PhD from MIT. Some of his numerous contributions include his pioneering models of dynamic traffic equilibrium, his work in probabilistic network analysis for lifeline planning after seismic events, and his groundbreaking work in life cycle construction project management and in green design. He has received over $6 million funding in research over the last decade alone, and I'm pretty sure I'm missing several millions there based on your CV. He has co-authored 7 books and over 250 journal and conference papers. He has received numerous prestigious awards, such as the Turner Lecturer Award of the ASCE. His great impact in our field is further attested by his nearly 10,000 citations per book scholar, and from his numerous students that hold very leading positions in some of the top institutions, of the top institutions in academia and in the industry as well. Professor Hendrickson, thank you for honoring us today. Please join me in welcoming Professor Hendrickson.
Very nice introduction. Today I want to talk about innovation in transportation and infrastructure engineering, and kind of talk a little bit about what's going on at Carnegie Mellon in that general domain as kind of an example of things that can be done. And I just mentioned the books that I've done, and I just might do a little advertisement for that. About 15 years ago, I took one of the textbooks I did originally, Project Management for Construction, and put it up on the web for free. And as a result, it gets a ton of use. I get an email about once a week from various people who are using the book around the world. About 5 years ago, I put up a book on civil systems planning, and so that's available on the web for free also. This past summer, I did a book on environmental life cycle assessment with my colleague Scott Matthews. Scott did a lot of the work, and so that's up on the web for free. And I'm hoping next year to have a book on infrastructure management. So I do the planning side, the project management for construction, and then infrastructure management, and hopefully that'll be up on the web next year. So anybody interested in kind of educational resources, I encourage you to go and take a look at that. But back to innovation in transportation and infrastructure engineering. I'll talk for 45 minutes or so. Interrupt me with questions or comments or whatever, and I'll try and reserve some time at the end for question and answer. So that'll be the plan. Well, I think we're in a domain that is very unusual, and I've been kind of working in the transportation realm for about 30 years, and there has never been a time like there is right now for transformative technology. this is just a number of the things that are happening simultaneously and throughout the world in terms of new transportation technology. First, there's connected and automated vehicles that are appearing, and the connectivity extends to infrastructure and it extends to people. All of you are probably walking around with a smartphone if you're typical college people. Smartphones have the capability for connectivity. And there's all sorts of vehicles that are being automated. Cars, trucks, bicycles, trains, they call it positive train control. Buses, drones, all of that is using this new set of technology. For the last 100 years, petroleum has been the dominant fuel for transportation. We have diesel for trains, diesel for trucks, gasoline for cars, diesel for cars. Suddenly, we're starting to see a number of other alternative fuels that are coming into use. Natural gas is of interest right now because the natural gas prices, particularly in Pennsylvania, are low because of the Marcellus shale, but they're substantially lower than petroleum. Electricity is starting to appear. Any of you have a plug-in hybrid car? Nope. Okay. You will probably sometime 10 years from now.
Stations.
You have some stations, okay. And ethanol. When I was growing up, the only thing you put into your gas tank is gasoline. Now, just about everywhere I go, it's 10% ethanol as a blend. Big data and information systems. That's kind of a general trend that's happening across a lot of domains, but it's really going to have an impact, I think, on transportation. More energy efficient infrastructure and transportation. Big implications for things like gas tax revenues to have a car vehicle fleet that's much more fuel efficient. And then in the infrastructure realm, we're starting to see a number of new materials and construction methods that are coming into place to deal with a whole series of problems that really hadn't been dealt with very effectively in the past. In addition to kind of technology opportunities, we've got a lot of kind of new and continuing challenges that require innovative approaches in order to make some progress on. Financial constraints. You talk to any manager of infrastructure, and the first thing they talk about is how starved they are for operating money for both new construction, renovation, rehabilitation, and maintenance. I mentioned the problem with gasoline tax revenues. In the United States, a lot of the gasoline tax revenues is set as a fixed amount. It doesn't go up with the price of gasoline or with inflation. Vehicles are becoming more fuel efficient, so they're not using as much gasoline, so the gasoline tax revenue is going down. The Federal Highway Trust Fund is likely to be bankrupt in the next couple of months, and so it's going to be a problem in terms of raising new revenues for doing things. Aging, growing, both in terms of numbers and in terms of size, and distracted population is a challenge. Distracted is particularly important for things like transportation, where people are kind of texting and doing other things rather than paying attention to their driving. Climate change. We're having more episodes of severe weather. We're seeing precipitation changes. We're likely to see the effects of climate change in a major way for all of your lifetimes, and certainly all of my lifetime. Safety concerns is something that's a continuing challenge. We have too many people who are fatalities in vehicle crashes. We have too many costs just coming from vehicle crashes, and that includes things like congestion as people have to back up behind crashes. Security of infrastructure and transportation. After 9/11, we've had to worry a great deal more about how to make things secure. There was an article in the paper a month or so ago about a researcher who took over a Jeep and took control of the Jeep's systems remotely. Anybody read about that? No. A few people did, yeah. It's scary to think that can happen if you're driving along the road. Regulatory and institutional constraints are a continual challenge to try and make changes that might be desirable. Recruiting a new workforce. We have this generation, the baby boomer generation that's gone through, and now they're looking to replace those professionals running transportation and infrastructure. And then, of course, environmental sustainability, trying to make sure our ecosystems maintain a productive and useful livability for all of us. So those are all challenges that are kind of at the forefront of transportation and infrastructure that we've got to deal with as a society and as professionals working in that general realm. Reminds me of the the old apocryphal thing, may you live in interesting times. We're living in interesting times right now. I don't think that the technology has changed so rapidly since the early part of the 20th century. So if you remember the early part of the 20th century, that was when vehicles came into use rather than horse and carriage. That was when airplanes were invented. Major technology transformation to the transportation world. We're having the same sort of transformative technology happening right now. So lots of challenges, lots of opportunities, and there are lots of innovative responses from a whole bunch of different organizations: business, educational institutions, government, private nonprofits, research. And one thing that's really new, I think, is that there's this new interest in partnerships among those different groups. It used to be that they were often siloed in terms of information sharing and working together. A lot more emphasis on trying to partner together. And in this talk, I'm going to concentrate on kind of our response at Carnegie Mellon University to this sort of opportunities and challenge. And I'm doing that with the hope that our experience might be useful to you folks. And it's not something that's unique to Carnegie Mellon. It's something that any university can start doing the sorts of things we are. So it's kind of a nice story to go out and tell people, and they can think about how it might work in their own circumstances. So that's basically what I'm going to be doing. A little bit about Carnegie Mellon, just to give you a perspective. We are smaller than you are. So this is the main campus. My office is right there right now. This is the kind of the core academic area. We have about 6,000 undergraduates, about 5,000 master's students. That's the portion of people who are growing the fastest, and about 2,000 doctoral students. The biggest cohort of undergraduates are in engineering. The second largest is in computer science. The third largest is in fine arts. So a very unusual mix for a university. We're a small place, but we try and really concentrate on having high quality programs. So we've been ranked #1 in computer science, #1 in visual communication, #1 in information and technology management. We have highly ranked MBA programs, drama programs, and of course engineering has always been ranked relatively high. So the story I want to tell is really about kind of the evolution of Traffic 21. And Traffic 21 was a new departure for us. It started in about 2008 with a local resident in Pittsburgh by the name of Henry Hillman, a very wealthy man, had a Hillman Foundation, and a strong supporter of Carnegie Mellon. And the story is that he was driving around Pittsburgh and came up to a red light, sat at the red light. There was no traffic coming the other way. He sat at the red light. And he thought to himself, you know, something should be done to try and make this work better, this transportation system, rather than just kind of sitting here at the red light. And so his idea was to try and give a challenge to the university to deploy new technology to make the transportation system work better in Western Pennsylvania. Okay? So the Hillman Foundation gave us a multi-million-dollar grant back in 2008. That led to the Traffic 21 initiative, which is what I'll talk about. And the initiative put together kind of seed funding for projects around campus, a strategic plan to try and develop a transportation program. In 2012, we competed and won a University Transportation Center program grant. And then again in 2013, we also competed and won another of the University Transportation Center grants. We managed the University Transportation Center and Traffic 21 basically together. My colleague Raj is technically head of the TSET Center, and I'm head of Traffic 21, but we basically work together on doing that. This past year, we decided after 5 years of activity that instead of just being an initiative, we would become an institute. And so now we're Carnegie Mellon University Institute. We have a new strategic plan, and we actually got new funding from the Hillman Foundation as a result of that. So that's kind of the history of where we are. So back in 2008, Henry Hillman's challenge really came at a good time. It was a bad time in terms of recession and all sorts of things going on in the country. But there were some really positive things that were available at that time. First thing is that a number of our computer science, robotics, information systems faculty were newly interested in what they called cyber-physical systems, typically called cyber-physical systems. Transportation is a cyber-physical system, and so it was something that they were interested in developing. A lot of them had kind of worked in virtual space for many, many years. Now they were interested in working in physical space in addition to the cyberspace. New technology appearing, and I already mentioned some of the new technologies that you can take advantage of, ready for deployment. And then again, this new interest in local government, and then the state in partnerships to improve performance. Started off in our case with the city of Pittsburgh, but then some of the suburban cities got interested, and they've kind of been growing. Wasn't universal when we started, but it's getting more and more entities that are interested in partnering as time is going on. So strategic goals of Traffic 21, stimulate and coordinate Carnegie Mellon's smart transportation research, promote education and workforce development, stimulate technology transfer, and we're trying to spin out companies, and we're trying to develop new entrepreneurial activity as we're going along. I should mention it's not just new entities, but also kind of working with existing industrial people. And we're continuing to develop the Western Pennsylvania region as a test bed for technology deployment as we're going along. And stop me with questions if you want. Well, I'll give you some examples of things that we're doing. So this is in the realm of bringing greater intelligence to users of the transportation system, so people like you and I. Park Pittsburgh is on the left here. Park Pittsburgh is an app that you can log into right now if you want to. And what it does is it keeps track of, in real time, of cars entering and leaving parking garages around downtown Pittsburgh. And so at any time you can dial into the application and find out how many parking spaces are available in the different lots around downtown Pittsburgh. So I use it if I'm going to go and see a Pirates game, our baseball team playing on a weekday evening. I'll be going down and saying, well, where's a parking spot available? And people use it for that type of thing. Interesting spin-off model for this. The original work was done with the Pittsburgh Cultural Trust, which had as one of its board members the individual who owned the private parking lots in downtown Pittsburgh. And he said, this is a great idea, and he's been supporting it. So he's the one who really puts in the resources to maintain Park Pittsburgh in its current form. The latest development for Park Pittsburgh is in conjunction with our Mobility Analytics Center, and that is Pittsburgh, the city of Pittsburgh went to a paid parking scheme where you went in and put your license number into a machine and you paid for parking for a certain amount of time in the local vicinity. Do you have that here in Buffalo? No, okay. Well, this is something that came in about 3 years ago into Pittsburgh. The result of that is you know how many people are parking in a local area in real time. And you compare that in the same way you compare the garages, you compare it to the number of spaces that are available, and you get a block by block estimate of how many on-street parking spaces are available. So we're in the process of trying to incorporate that into the parking program. Tiramisu is another good story. It's a crowdsourced bus information system. So if you download Tiramisu, you can volunteer to provide information, and you can receive information. And so I'm a Tiramisu user. If I get on a bus, it'll come up and say how full is this, you know, a little scale, and when did you get on the bus, and then it'll track my progress as I'm going along using my smartphone as a GPS recorder. And so in a place, right, say around Carnegie Mellon, where there are a lot of people like me who are willing to volunteer and have smartphones, you get pretty good, accurate data. Places where you don't get that real-time data, Tiramisu just uses the regular scheduling to tell you whether it's real-time data or whether it's scheduled data. Interesting thing about Tiramisu, it's now been extended to multiple cities, but our local bus company decided that they might as well provide real-time information also because it was available anyway. So now they're putting out real-time information about bus locations. And so Tiramisu has a feed from the bus company in addition to the crowdsourcing for information. Tiramisu is still the only place you can get and whether or not there's seats available or not on a bus. I won't say too much about NavPal. It hasn't really come into widespread use. It's essentially an aid for navigation for people with disabilities. So it provides voice information about how to get around in the city. Okay, that's the users. Then we have a whole series of things on bringing greater intelligence to managers of the transportation system. One thing that the city of Pittsburgh is taking advantage of is a video-based pothole identification and roadway defect identification system. This came out of our Robotics Institute. I played with this 15, 20 years ago, and back when I did it, we had multiple sensors. They were all pointing down at the roadway, and we did distance sensing and that type of thing. Software has improved since the time that I worked on that. So Christoph just uses a pretty inexpensive camera, just going straight out of the windscreen. All the manipulation to do the 90-degree rotation and the pavement defects is done in software, and the system is more reliable than the system I had 15, 20 years ago. And so that's available now. Christoph is now trying to extend it into snow identification and that type of thing. You could have this mounted on any sort of vehicle. Christoph has been driving around in his own vehicle. I think things like trash collection vehicles would be a good sort of test bed for doing this. Smartphone-based road inspection. I think I said all this. One thing they're doing is trying to extend into sign recognition, and this is a display, just a visualization of road condition around Pittsburgh based on the system. Stop sign inventory, right? Another example of managers. We are experimenting with putting accelerometers and sensors on light rail vehicle systems. The original application was to do real-time monitoring of bridge condition over time. Jacobo was one of the investigators on this project. turns out that the real usefulness of this is for track identification. If they started to find places where the track was starting to wear down, and they could send out and direct maintenance activity to that. And I think that this sort of a system probably has some real possibilities for improving track monitoring throughout the railway network in the United States. So that's kind of an interesting system. I think I said all this. Yeah, indirectly monitors the vibrations from tracks and bridges, detects and flags changes over time. So real-time gathering of information in vehicles can then be used for helping to improve the management of the system. We had a special interest in trying to do something about traffic signals because of the story about Henry Hillman. So one of the early projects was to take advantage of kind of machine learning, what I grew up calling artificial intelligence, and now they call machine learning approaches to try and improve traffic signal performance. And so we have an adaptive traffic signal program called SurTrack. It started off with about 8 intersections just north of Carnegie Mellon. It's based on, as I said, machine learning. It does communication between the intersections. Steve Smith, who's the researcher in charge of this, has been noticing that the travel time improves, the number of stops goes down, the wait times start going down. And this is something that provides real benefits to the people traveling through the network. The controller, by the way, has communication between intersections, so that one intersection will know what the schedule is for the intersection upstream of where it is. And since it's doing a new schedule every few seconds, you can react to events that are going on. System uses just video identification of vehicles. That's kind of what Steve put in place. Seems to work perfectly well. He's using just kind of off-the-shelf software for vehicle recognition. We're in the process of expanding SurTrack to something like 50 intersections in the vicinity. That's the next slide. Interesting. Anybody ever looked in a traffic signal control box?
I have
A metal box? Okay, yeah, you do it all the time. So back when I was working on that, they have a traffic controller computer, really old technology, and then a lot of wiring and that type of thing in the boxes. Well, the boxes for SurTrack have boards for all the video identification, has a board for the SurTrack program itself that plugs into the old-time controller and overrides the controller's strategy, and then it has a communication board. So you look in the traffic signal controller, and there's a lot more intelligence. And the nice thing is that the cost of the intelligence has been coming down, and so it isn't that expensive. The cost of the people going out and installing it all is still pretty high. So that's where the real costs come in. Okay. This is kind of an east-west corridor in Pittsburgh. This is the goal for this year. This is the part that's actually working. These are still under development. 40, I said 40, it's 50 intersections. Carnegie Mellon is down here. So, by the way, SurTrack is not the only adaptive traffic signal controller. There's some competitors out there, but I keep getting stopped at traffic signals. I stopped at a traffic signal in Buffalo, and I thought to myself, I sure wish SurTrack was here. New initiative, Mobility Analytics Data Center. This is Sean's work, and the idea is to take in real-time information of a variety and provide useful information to different groups like public agencies, travelers, private sector. There's a number of systems that provide real-time information like this around the country. I think what we're trying to focus on is providing useful information for decision making. So the sorts of examples, public agencies, one of the applications that Sean's working on is there's a bridge that's going out in Pittsburgh. What do we do about managing the traffic around the bridge outage for reconstruction? Working with trucking companies to provide information on when to schedule truck deliveries for congestion purposes. Working with travelers for trip advice and trying to do things that aren't Google Maps, that might maybe be a little more forecasting of what's going to happen. Google Maps, anybody use Google Maps? Yeah, it basically is giving you the situation right now, doesn't really have a forecasting capability, so Sean's interested in trying to do some updates on forecasting for that. Let's see, anything, transit operations I already mentioned, parking I already mentioned, those can be added in. Traffic counts, that's an interesting thing. Both for SurTrack and for this mobility data engines, we're trying to develop software that will recognize bicycles and pedestrians. Bicycle software works pretty well at this point, and it's just a matter of kind of implementing the video to go out and identify bicycles. Pedestrians are tough. There's still, some type 1 errors in terms of recognize who's a pedestrian, who isn't a pedestrian. You get all these complications like baby carriages and that type of thing. So it's still work in progress, I'd say. But it's important because, particularly for things like traffic signal control, you want an automatic way to recognize when pedestrians are waiting so that there's no frustration in the people trying to cross the street. And I think the technology will get there pretty soon. Social media, that's another one. So, any of you do use Twitter? Okay, so we have a group that's looking at taking Twitter feeds and identifying traffic-related words that might indicate things like crashes, incidents, and then using that to supplement the regular databases about where crashes are occurring. Turns out that you see a lot more crashes out of Twitter than you do out of the official statistics, but it's unclear how important the crashes are. Some of them are probably tens of numbers. Anyway, research in progress, different sort of data feeds, what normally occurs. Okay, that was better information for users, better information for managers, greater intelligence to vehicles has been another kind of project for us. We have a group that's working on bicycle technology. How do you get a bicycle to be safer, communicate, that type of thing? I think that the same technologies can help out for pedestrians. I'd love to have a connectivity to tell people not to cut me off as I'm crossing legally with the right-of-way over streets. We've had a project on headlights that are using advanced technology to see through snow and rain much more effectively than just light. The motor vehicle manufacturers may be catching up to us, though. It's hard to stay ahead of some of those people. So I think an improved type of headlight is going to be coming out soon, which I'm all in favor of because the current generation is blinding as far as I'm concerned for driving. And then autonomous vehicles, and I'll talk a little bit about autonomous vehicles. The one in the picture here is Boss, and that competed in the DARPA Urban Challenge a few years ago. Before I do that, I'll just mention alternative fuels. We have several groups on campus that are interested in alternative fuels. One is interested in using natural gas, both in terms of direct use in compressed natural gas, and secondly in converting natural gas into liquid fuels. And that's both a systems problem which is the part of it that I'm interested in, but it's also a chemical engineering problem to try and improve the process, going from gas to liquid fuels. Battery-powered electric vehicles, also of interest. Again, it's both a systems problem in terms of how you make things work, what sort of infrastructure you provide, where you provide it. It doesn't really improve the environment given the current mix of power generation in different parts of the country. Pittsburgh is problematic, by the way. And then the real thing that's going on in battery-powered electric vehicles is trying to improve the battery. I took a first look at battery-powered vehicles back in the early 90s when General Motors came out with a zero-emission vehicle called the EV1. It was based on lead-acid batteries. And one of the life cycle studies I did, the first life cycle study I did, was to argue that, gee, if you look at the entire life cycle of lead-acid batteries, there's a lot of lead that gets out into the environment as a result of this technology. And this is not a zero-emission vehicle, only zero emission at the tailpipe. Batteries have improved since that time. Now, of course, the dominant battery for battery-powered electric vehicle is lithium-ion, and that, of course, is much less toxic and has fewer environmental problems than the old lead-based technology. Oh, back to autonomous vehicles. A bunch of you earlier were asking me about autonomous vehicles. The BOSS that I put up originally was 2007 generation. That was under the direction of Red Whitaker. 2012, the Cadillac came into use under Raj Kumar. We have had 30 years of automated vehicle research going on at Carnegie Mellon. We did a little celebration, and this is a poster from the celebration this past year. The 1984 version was called the Terra Gator originally. It was about the size of the table over there, or one of the tables in this room, six-wheeled, traveled at slower than a walking pace. Originally developed to be completely manually controlled, and the original application was going into the reactors at 3 Mile Island and Chernobyl. The research team quickly said, well, we have a lot of computing on here with video. We can start doing automated driving. Tell you a story about one of the first versions out. There's a park right beside Carnegie Mellon called Shenley Park, beautiful park. And it has paths that kind of go winding around through the park. The Terra Gator was out there running around on the path that was curving, and it was programmed to follow straight lines. So it decided to try and climb a tree rather than follow this curving path. Technology's improved since that time. So that was 1984. You can see the different generations. There was a big van called NavLab, then down to BOSS in 2007, and then the Cadillac in 2014. And it's nice to see technology like that started off really quite primitive, and now you can drive the Cadillac in mixed traffic. And Google, of course, has put on 1 million miles using the same sorts of technology. And just another illustration of how the technology has improved. The left is the trunk in BOSS. The right is the trunk in the Cadillac, and all the computing has been put down under that hatch there, so that you got your full trunk space. Connectivity, dedicated short-range communication is another technology that's coming into use. Vehicle to vehicle, vehicle to infrastructure, vehicle to other. We have a number of intersections now in Pittsburgh that have dedicated short-range communication. All the SurTrack ones do, because that was something that Steve put in. We had a little study for PennDOT to give them advice on things that they might be doing. In the short run, we told them, really take a look at capacity expansions about whether you really need those, because they're going to be around for 50 years and the vehicles are going to change. But the other thing we told them was start getting ready for this dedicated short-range communication. So they're starting to put it into all their newly redone intersections. As far as I know, right at the moment, the only vehicle we've got in Western Pennsylvania who uses the dedicated short-range communication is the Cadillac, which only goes out of Katy. One project I didn't mention with SurTrack was that they're going to use the DSRC on the SurTrack controllers and put in bus preemption. So the idea is to equip all the Port Authority buses with DSRC and then have SurTrack react to the buses coming up to the intersection. And I think that'll be an improvement too. This was the demonstration I talked about earlier. This is from Cranberry out to Pittsburgh. I won't show the video. If you want to YouTube, go ahead and YouTube it. You can see the trip with Phil Schuster and the PennDOT secretary back September of 2013, and you can see them driving along. I've mentioned along the interstate here, the Cadillac is designed to go only, it's programmed to go only 55 miles an hour, the speed limit. So you watch the video and you just zip it around, cars are zipping around the Cadillac as they're traveling along. We did another demo down in Washington, D.C., which was a real headache because we had to equip all the signals around the Capitol with DSRC for the Cadillac. That was I think that will be a one-off only demo. And we've had several cars travel across the country in a driverless mode at this point in time. So this technology is getting to the point where it's feasible, technically feasible, and the issues are now in the regulatory domain and in the legal domain and in making sure that the systems are really reliable. And just to give you an idea, this is about a year old. Autonomous vehicle legislation is starting to appear in a lot of different states. New York had one under consideration at this time. Pennsylvania, we called up the Pennsylvania state troopers, the head of the state troopers, and said, is it legal for us to go around Pennsylvania with a driverless vehicle? And they said, as long as you've got a driver in the seat, ready to take over immediately, you're legal. So that was their position on it. I won't say too much about this. This was the study that Al Beeler and I did for PennDOT on what things might change with connected and autonomous vehicles. Infrastructure investment and design. It could be we can get by with narrower lanes with automated vehicles because you've got lane following. It could be that you can do platooning and get better capacity. Communication devices, I already mentioned DSRC and real-time data use. Driver licensing. What's going to happen with driver licensing? How should the driver's licensing test change if you've got vehicles that can park themselves? When I did my driver's test, that was the first thing they did. You know, you did parallel parking. Well, if nobody needs to do parallel parking, we really need to test that anymore. Workforce training needs, freight movements, all of those are going to be changing. Freight, Pennsylvania has an interesting problem. We're an agricultural state, and there's a lot of farm equipment that has to move around in Pennsylvania. And it turns out that that's hazardous. There are a number of crashes associated with moving farm equipment. So there are regulations on when you can move, what sort of permissions you can get. With connected vehicles, it's going to be a heck of a lot easier to move farm equipment around from field to field and place to place. Same thing with oversized vehicles of any kind. So this is evaluate plan capacity enhancements, collaborate with the private sector to convert data into information. PennDOT, like many other transportation agencies, just has a whole bunch of data that they have, and traditionally they've sat on it rather than providing it for decision making. We're into a new and begin deployment of vehicle-to-infrastructure applications in key locations. Driver license training for emergency circumstances, trucking to change safety and enforcement, deploy equipment, revamp workforce training. And then in the long term, you can start thinking about different lanes, dedicated lanes for autonomous vehicles, providing for a new license class for those wishing to drive their cars manual. These are all changes that I think are going to be coming in certainly within your lifetime. And policy implications, heck, for autonomous vehicles, you can think about all sorts of things. Safety is going to change. Crashes should come down. The frequency of crashes, the severity of crashes should be coming down. We should have much better mobility for particularly the elderly and people with disabilities. Congestion and vehicle miles traveled are likely to change quite a bit. Public transportation, a lot of costs associated with paying drivers in public transportation. How do you go to automated systems, making sure fares are collected and that type of thing. Energy and environment, you can program automated vehicles to be more energy efficient in how they drive. Land use, if people can, do their office work while they're driving into the city, maybe they'll want to live further out. Economy and jobs, you've got taxi cab drivers who are already worried about what's the future of their job going forward. And I'll say a little bit about Metro 21. So I talked all about Traffic 21. I've given you kind of the overview of Traffic 21 and kind of what we're doing, where we're going. Metro 21 is a new initiative. And it is essentially doing exactly what I talked about for Traffic 21, but for all urban systems. Okay, so the idea is to take advantage of new technology, start up seed funding in the university to get some good ideas going, and emphasize deployment, work in partnership with the local industry and local government to try and improve the way all urban systems work. So Traffic 21, in our view, is a subset of Metro 21. It's the subset that focuses on transportation. It's a big subset, and for us, it's something that's fairly established, and we're trying to get this Metro 21 idea going. All right. We won't have, that's the mayor who's talking about the partnership. I said research, development, deployment through partnerships. We have a memorandum of understanding between Carnegie Mellon and the city of Pittsburgh to share information, work on deployments, that type of thing. Give you a sampling of a couple of projects in Metro 21. This is a Yelp for renters, okay? The idea is that renters can go in and provide information about individual rental units. Owners can go in and put information about individual rental units. Students love this idea because it provides them some new information. Anybody use Yelp for restaurants and that type of thing? Yeah, okay, you get the idea. And instead of doing restaurants, we're going to do rental units. And not to take advantage just of the restaurant reviews, but also kind of information from the city on what the condition is and that type of thing. We had a group that developed a cheap particulate matter sensor. It's pictured down on the bottom right. It turns out Pittsburgh is a city that is not in attainment with the particulate standards, and localized areas can be fairly poor in terms of the particulates near construction and that type of thing. So this sensor, we have a pilot program where they're available in the library. You can check them out just like a book, take them home, and monitor your particulates in the air for as long as you want to check it out in the library and then return it. Combined sewers is a big problem in Pittsburgh. So the idea here is to try and take advantage of some new technology and trying to green infrastructure for water control. Sorry, I'm running out of time, so I can't do it too much. You're looking at an old steel site in Hazelwood. It's the largest undeveloped piece of land in the Pittsburgh region. It's right along the Monongahela River. Carnegie Mellon University is right up in here. The city would very much like to develop this. The problem is getting in and out. The access is poor. A lot of the infrastructure is poor, and so we're going to try and make this into a smart city application as it gets developed. You all have 311, 511, 911, all of that. Well, in Pittsburgh, all those response centers never communicate with one another. They're silent, completely silent. It would surprise me if that isn't the case here also. And so this project is trying to put all that together along with health information so that you got kind of a consolidated picture of things that are happening around the region. Underground utilities. Again, they're siloed for us. There's a different entity responsible for all of this. It's hard to even know where a lot of this underground utilities are. And so this is a project just to start off mapping and then build a database and build a visualization capability, that type of thing. 2 weeks ago, the Metro Lab network got announced, and this is our kind of attempt to try and partner with a bunch of universities and cities around the country. Each of the stars up there represents a participant in Metro Lab. Each of them has the same sort of memorandum of understanding that I just mentioned between the city of Pittsburgh and Carnegie Mellon. And our hope is that this will lead to sharing of best practices and to opportunities for collaborative research. And so, as I said, it's just starting. Here's a list of the universities. New York has one for New York City partnering with New York University. You can think about a Buffalo. Pittsburgh is partnering with Carnegie Mellon University, of course. So that's the story. That's the Traffic 21 and now the Metro 21 story. One of the things that makes it work for us is that we are consciously trying to be interdisciplinary. So we're drawing from resources all over campus. The largest number of researchers in Traffic 21 actually comes out of computer science and robotics, which is about the same size as engineering for us. After that, it's kind of engineering, and then public policy, our Hines School, and then places like architecture. And so we're consciously trying to work with other people. I just found out that our CERT, our internet security people, where's your internet? He left. So our CERT people now have a project on vehicle security, and we're given a vehicle, and they're trying to hack into it, and that type of. I keep finding these things and finding opportunities for new partners around the campus. So you've got to keep looking for opportunities like that. So that's my story. Happy to answer any questions.
Thank you. So are there any questions for Professor Hendrickson? Yes.
I'm working for the cognitive engineering lab, so I have two questions actually from the teacher's perspective. One is for the parking maps. So I think that providing the real time of the parking lot. But my question is this just to provide the information to the users, or there's any strategies integrated with the users that you can guide the users?
That's a great question. And that's on the list for the Mobility Analytics Center. And you're absolutely right. If you keep track of who's asking, you should be able to get some information about how many new parkers are getting into the system, and so you get information about how much competition might be occurring. Same sort of thing happens with Google Maps. Okay, I go onto Google Maps and I ask, well, what's the fastest way to get from A to B? And there's no forecasting. If there's a huge number of people who ask the same question for Google Maps at the same time, they're all going to go on the same route that Google Maps recommends, and it's going to be very congested. So, good question. Don't have the solution right now, but you start to think that if people are willing to share their plans, I'm going to go in and use this parking spot or put in a reservation for a parking spot even. You could start thinking about it, a technology or an app that could do that sort of forward thinking. Not there yet. Great question. Does have some potential.
Another question is for the connected housing technology. I've seen such a product also developed in Europe, and I also see the sensors installed on the bicycle. I'm just interested in are there any information provided to the drivers in real time in how the technology works? Like if it's audio warnings, or it's visual displays, or a tactile?
This is all stuff that's just being worked out. And that's the idea, is to provide information about where locations are. So for the bicycle, what you'd like is information about, is there a car about to hit me? Yeah. So, no, this is all in the research domain at this point. Great questions. Yeah?
Question on freight. Given that the volume of freight we move across our country, much of it's moved by rail, I sense there's not much communication between the trucking companies, the rail companies, and indeed the rail companies amongst themselves, because perhaps they use dedicated infrastructure. But there surely must be some opportunities to improve the way we move goods across our country.
Yes. I wouldn't say there's no communication. A lot of the railway companies have really worked hard to make their intermodal operations effective, and so there's this communication between the rail companies and truckers about kind of taking containers and moving and pick up and that sort of stuff. So that all works pretty well. The parts of it that don't work very well are things like unsignalized rail crossings. We happen to have a number of crashes in this country that happen there, and so you'd really like better ways of warning people, keeping people off tracks, and that type of thing. Another one is the port interaction. Places like Long Beach are just major generators of truck transportation, and it's a major problem for the local areas around there in terms of congestion and air emissions, and they could do a better job about interacting with the local communities on that sort of score. The only people they interact with are the truckers, to tell them when cargo is available and when they can enter and that type of thing. And as a result, I was in Long Beach not long ago, and I watched, must have been 100 trucks lining up, just waiting for their opening to get into the port. And that's just a waste. So yes, I think there's all sorts of possibilities for improving how the freight system works using these sorts of new technologies, both big data and kind of the real-time connectivity that you have available.
Any other questions?
Could you comment more on the Highway Trust Fund? You said the Highway Trust Fund will deplete in a few months. What happened after that?
You know, you talk to all the state highway people, and they just throw up their hands, because they're the ones who are doing the actual programming for the projects. And they're just living in uncertainty right now. And it's very difficult to try and program projects if you don't know whether you're going to be getting federal funds. And of course, Congress just can't get the gumption up to try and increase the gasoline tax for political reasons, and keeps just kind of kicking the can down the road. Back 20 years ago, we would get a highway bill that would have 5 years of funding and projects just on a regular routine basis. And we haven't had that for the last 6 years or so. And it's a major problem in terms of managing the system and having continuity and all the other things that you'd like. It is really expensive to do fit and start sorts of roadway works or any sort of construction work. And so this is going to be a real cost that we have in the system. What's going to happen? Your guess is as good as mine. I read the reports of how it's hard to find a new House Speaker, for example. I was kind of hoping in this session running up to the election, we could have some kind of grand bargain struck on things like the transportation bill, but I'm getting less and less optimistic on that, I gotta say. Now, in contrast to that, there's some real movement in a number of states. I don't know whether you noticed that Pennsylvania increased their tax revenues from gasoline last year. And the way they did it was there was a ceiling on the amount of taxes that were paid by refineries under a refinery tax. They took away the ceiling, and that gave you revenue to the state DOT. And so they've been gearing up a program for bridge rehabilitation and that type of thing, which is going on. So there are a number of states that have that same sort of story going on. And it could be that we're going to go from primary reliance on the federal government for funding to state initiatives. That's a possibility. And of course, the keystone of the federal system was the interstate system to get it built, and now it's built, pretty much. So big changes. Yeah.
You mentioned about the autonomous cars and like Cadillac. The ideal thing that I think is that all of the cars are good with that system, so they can communicate with each other and avoid any crash. But at this point, where we have lots of cars without that technology, as I think some crashes have just one unique way to avoid. And that must be the driver's reaction to that incident. So do you think we can reach that the point in the near future, so the cars can find that unique reaction to avoid that collisions?
It depends on the type. Some are harder than others. Rear end collisions, the technology really already exists. You can cut out rear end collisions by putting in systems that'll just stop the car or stop the vehicle. Other things like running off the road, that's harder. You got to take over control of the steering, and people are reluctant to allow that and want to override it, and so that's going to be a hard one to try and automate out of existence.
Because I think, okay, so even if the driver sits on the autonomous car and wants to take over to the reaction, that reaction time increases. So this driver is not ready for that.
Yeah, the machine will have a better reaction time. The question is whether it's reacting to the right thing and recognizing it as well as the human is. And so these are all things that are going to have to be worked out. And we're working them out kind of piecemeal right now with the partial automation systems that are already for sale and already exist on the road. And so we're starting to get some evidence that those things really can make a difference.
Can I add something to that?
Sure.
Actually, automated vehicles, in the long run, you're expecting them to create the conditions that would lead to safer roadways. So you wouldn't have these incidents that the human behavior would play a role. So eventually, there wouldn't be any accidents if all vehicles in the whole network are automated.
I don't know whether we'll get to, there will never be.
Yeah.
We can reduce crash frequency and severity. Yeah?
Just to follow on to that discussion a little bit, how difficult do you think it is going to be for the public to adapt and to actually start using connected vehicles?
Yeah, well, about 3 weeks ago, I got this email from a person who's blind, and he said, "Well, I'm looking forward to this technology coming in." And the test drives that we've done, people seem quite content with it. The YouTube that I was just talking about, where we had Bill Schuster and the PennDOT secretary, and they started off kind of watching the driver and watching the things, and then after a while they were just conversing among themselves, and they accepted the technology without really worrying about it at all. On the contrary side of that, I think that we are never going to get to a situation in which all the traffic is driverless. I think there's going to be a proportion of people who want to drive, enjoy driving, want to drive, and one of the questions is where they might be permitted to do that. Could be on rural roads or something like that, I don't know. But that's a long time in the future. Okay, thanks. Oh, sorry.
So again, about connected people. So as a matter of affordability in the future, is there going to be any chance for everyone to own one of those cars? About the price?
Yeah, the price. As I say, the price of the technology keeps coming down. And you already see that in the partial automation that exists. It's dropped in half. And so if you've got a car that is more fuel efficient because of the programming and is less prone to crashes, so your insurance goes down, the hope is that those savings will outweigh any technology costs. And of course, technology of this type that we're talking about has strong scale economies. You get one software system and you can put it in millions of cars. Volkswagen demonstrated that. But you get one that works and you can put it into millions of cars, and the incremental cost of the additional car is very small. And the technology for things like video cameras and computing and that type of stuff, that just keeps going down.
Let's do one last question.
Okay. All the connected vehicles, all the autonomous vehicles, are they still in the progress of researching, or they are already running on the road right now?
They are running on the road, but it's really still in the research domain for connected vehicles. The biggest demo that's going on, you can go and take a look at what they're doing, is in Michigan. And there's another couple that are going to be developed with kind of 10,000 vehicles and that type of thing. So they're running on the road, and they're looking at what sort of applications would be cost effective.
And another question is, so all the connected vehicles, they are connected in a shorter range. Are they connected online, controlled by a single computer somehow, or just one individual car?
Well, when you got short-range communication, say you go by a traffic signal and you send a message, I'm traveling here. Well, the traffic signal can communicate to the cloud.
Oh, so yeah, that might cause a potential either for hacking.
And there's still debate about what's the appropriate frequency for the dedicated short-range communication, and how it might connect to the internet and all that stuff. It's still undecided. There's competition for the spectrum. And the Wi-Fi people would love to move into the spectrum that's been reserved for transportation. So it may end up integrating.
Well, thank you very much all for your attendance. Professor Hendrickson, thank you very much for the very informative talk and for visiting us. Please join me.